Hi once again. Uh, Today we want to discuss questions from the past exams, uh, and these questions were gotten from different papers under algebra, mostly factorization and simplification of algebraic fractions. But today we'll just discuss the factorization methods. Mostly this part comes in paper 1, so we can quickly go into example 1, which is saying factorize completely. We have 32x squared minus 50, and this question came from GCE 2019, last year's paper, and it should be in paper 2. Alright, so we are saying factorizing that one, so it should be factorized completely. Remember, we said when you factorize, there should be no any other number apart from a 1 that can be divided into that expression. So we have 32x squared minus 50. So we are factorizing. We are saying we look for a factor of 32 and 15, the highest common factor. We are going to see that it will be a 2. So we factorize a 2 and factorize a 2 from 32 to give us 16. X squared is just a variable without any other common variable, so it doesn't have a common factor. Then if you factorize 2 from 50, we get 25. Some of us might think this is the answer, but this is not yet the answer, because in the brackets here we have another factorization method. So the method that we have used at first is factor factorization, then the other one inside the brackets. In the brackets it will be a difference of 2 squares. We know that 16 can be written as 4 squared. There is also x squared minus 25 can be written as 5 squared. It can be written as 5 squared. We can proceed. We can have outside the brackets we have a 2 for what is in the brackets. For a difference of 2 squares, we write the first bracket to have a 4 and x, because those are the square roots of 16 and x respectively, minus the square root of 25. We said it's 5, and close the brackets. The other pair have the same numbers and letters, but in this case it will be a plus 5, and we close the brackets. When we look at this answer here, it's just telling us that there will be no any other factors that can go into what is in the brackets and outside the brackets. So this one will give us the answer for question A. So if you look at these questions in the question papers, somewhere here you'll be given 1 mark, and somewhere there you'll be given another mark, so that you have 2 marks. So that's how we factorize completely. You can go to example 2. Example 2 equally, it's saying factorize completely. It came from ECZ paper, which is 10 of paper of 2018. So we can make out this one as follows. We can say we can make out this one as well. We can say we have 18 minus 2x squared. This will give us, so first of all, let's look at the factors of 18 and 2. It's just a 2, so we're going to have 2 into 18, it's 9, minus 2 into 2, it's 1. 1 times x squared, it will just be x squared. Then we can proceed, we can write a 2. When we look at what is in the brackets, we can write them in terms of the squares. We can say it's 3 squared minus this one is just x squared. So the square root of 9 is just 3, and the square root of x squared is x, close the brackets. The other pair of brackets will have 3 plus x. So what you are looking at here is a combination of factorization and then a difference of two squares from brackets here. Difference of two squares. This one will be our answer. Alright, we can go to example 3. It's saying factorize completely ax squared of ax squared y minus 4ay cubed, and it was gotten from ECZ 2017. I'm sure it's paper 1. So we are saying, first of all, let's try to look at what is common, the common factors. You can see that there is a there and a there, there is y there, y there. So for a, saying it's a common factor. Y also is a common factor because y can go into y and y can be divided into y cubed. So if we factorize ay from ax squared y, we'll just getting or remain with x squared minus, we factorize ay from 4ay cubed, we will remain with 4 and y squared, close the brackets. Then we have ay, and we know that this x is just x squared. It has got a square root. 4 can also be written as 2 squared, and y is just y squared. It has got a square root. From there, we can proceed by saying ay, we open the brackets. The square root of x squared is just x minus the square root of 4, which is just a 2. The square root of y squared is y, close the brackets. The other pair of brackets will have x plus 2y, and we have factorized completely. The last example in this session came from GCE 2017. So we are saying it has x squared over 4y squared minus 1 over 9. We are saying factorize completely. So in the first place, we need to look or identify this question. Is it falling under factorization or a difference of two squares? So it qualifies on a difference of two squares. Why? Because x squared has got a square root, 4 has got a square root, y squared has got a square root, 1 has got a square root, and 9 has got a square root. So we'll write in brackets to say first of all. So here there are no common factors. We are not going to factorize using factorization, but it's a difference of two squares because there is also a minus. Okay, so the square root of x squared is just x over the square root of 4 is 2, the square root of y squared is y, minus the square root of 1 is 1, the square root of 9 is 3, because 3 times 3 is 9. Then the other set of brackets will just be the same variables, but here instead we write a plus 1 over 3, and this one will be our answer. Thank you very much.